Hello everyone, I am Prajwal and today we are going to look at this problem forest gathering. This problem is rated as easy on CodeChef and you require basics of binary search to solve this. So guys, if you haven't read the problem yet, go back and read it, try it out and then come back and see the solution. With this, let's begin. In this problem, Chef has bought a piece of land in which he has n trees. Each tree has initial height h of I. So we are given an array of h as h1, h2 till h of n, where h of I is the height of the ith tree. We are also given the growth rate of the tree r1, r2 till r of n. Basically these trees grow at different rate. Hence we are given that the first tree whose initial height is h1 will grow at the rate of r1 meters per month. Now Chef wants to cut these trees in order to get wood. In this city, there's a law that you cannot cut a tree whose height is lower than L meters. So, if there is some tree T whose height is less than L, then you cannot cut this. Now, Chef has received an order of W meters of wood. And he has to fulfill this by cutting these trees. So, it might be possible that if he cut all these trees, then he might not get W meters of wood. So he has to wait some months such that these trees grow and then finally when he cuts them, he will get at least W meters of wood. In the problem, we are asked to find the minimum number of months that the chef has to wait such that he can fulfill this order. Now chef wants to fulfill this order as soon as possible. In the constraints we are given that the number of trees can be from 1 to 10 to the power 5, the order of wood and the limit of the trees which can be cut can be from 1 to 10 to the power 18, the height of the tree and the rate of growth can also be from 1 to 10 to the power 9. Moving on to the test case. In the first test case, we are given the number of trees as 3. The order is given to us as 74 and the limit from which we can cut the tree is given to us as 51. Now the descriptions of trees are given. The first tree has height 2 and rate of growth as 2. The second tree has height 5, rate of growth 7. The third tree has height 2 and rate of growth as 9. So now in the month 0, that is we do not wait, initially we have 2, 5 and 2 as the height of the trees. Since all the trees are less than the L which is equal to 51, we cannot cut any tree, hence the total amount of wood that we can derive is 0. In the first month, we still have 0. In the second month, we have 0. And till month 5, we cannot cut any tree because even after growing, their height remains less than 51, which is the law. Hence, in the month 6, the third tree actually reaches beyond the limit of 51 equal to 56. So this will contribute to the wood that we can obtain. Hence it is equal to, hence the total wood that we can get is 56. But this is still less than the limit that we need, which is equal to 74. So the chef will keep on waiting. In the 7th month, he will see that the total wood that he can derive is 119. It can be derived from the second tree whose height is now 54 and the limit was 51. Hence we can cut this. The third tree has height 65, so the total he can derive is 119. We cannot cut the first tree because the height is still less than the limit, which is equal to 51. 7th is the first month after which the chef can actually fulfill the order of 74 meter of wood. So the answer is 7. Moving on to the solution. In this problem, we are given n trees characterized by their initial height and the rate of growth Ri. Now, we need to find the minimum number of months such that we have at least W amount of wood. To find the minimum number of month, we can use a linear search approach. Basically, it means that we will iterate from m is equal to 0 to infinity and we will calculate the amount of wood that we have in the mth month. For example, let us say that initially we have 0 height of wood. Now we can iterate over all the trees and if the height in the mth month, which is equal to h of I plus r of I star m, this is greater than equal to L. L was the limit after which we are allowed to cut the tree. So if this is the case, then we increase our wood by h of I plus r of I star m. Basically, we do this because let us say that this is the time span, and to find the minimum number of months, we iterate at m is equal to 0, then we see after first month, then we see after the second month whether it is possible to get w or not, then we see after third month, and so on. Let us say at some month m we see that the total amount of wood that we can get is greater than equal to w. Then this will become our first month in which we can fulfill the order. Hence, we will output this month. So finally, we just need to check that if wood is greater than equal to w, we have our month as m, and we initialize answer to m and break. Finally, we will output the answer. So the subtask 1 has n, w and l till 10,000. Hence, this solution will pass subtask 1, however, will fail for the second subtask. Moving on to the final solution. Now it is pretty much clear that we cannot use the above linear search approach to solve because the amount of wood is less than equal to 10 to the power 18. And if we iterate over the months, in the worst case, we have to iterate from 1 to 10 to the power 18, which will give you daily. So we will now formulate another solution to solve this. Now let us say that we have a time step such that in some month m we are able to fulfill the order of size w. This means that we have at least w amount of wood in this month. So the observation here to note is that in the consecutive months after this month we can fulfill the order of size w because the height of the tree will keep on increasing if the chef waits. Hence, after all these months in the month m, m plus 1 and so on, we can fulfill the order of size w because we have at least w amount of wood. So this is the classical observation that is needed to apply the technique of binary search. Another way to look at it is as using a graph. Let us say we plot time in the x-axis and the amount of wood that we have in the y-axis. So at time 0 we initially have some wood and this will only increase with time, and at some month m we have a required amount of wood w, or at least it is greater than equal to this amount w. This graph is actually monotonic, and binary search can only be applied in the graphs that are monotonic, that is they are either increasing or they are decreasing. This graph is increasing, hence we can use this approach. To apply this, we will take a range low and high, and we will assume that the answer lies in this range. So for our case, we can take the low as 0, and let us say we take a very high range as 10 to the power 18 plus 1. Because the total amount of wood that we need is 10 to the power 18 and the rate of growth is at least 1, the number of months in the worst case we require is 10 to the power 18. Now to apply binary search, we will go to the middle element and we'll check whether the amount of wood we have in this month is greater than equal to w or not. If the answer is yes, that means that we are actually in this range. So to move towards the minimum, we need to decrease our upper bound. So our range will now become as the low will remain the same, but high will be equal to now the mid value. But if the answer is no, that means that we are actually in this range. So to move towards the minimum month, we need to increase our lower bound. So this will change as high will remain same, but we will initialize low to mid. We will perform this step until low is equal to high. In this case, the lower bound is equal to the upper bound, hence we are at the mid value, which is our answer. To implement the above solution, first of all, we will take our range, which is low and high. Now, we will iterate until low is equal to high. And in this case, we will calculate the mid value, which is low plus high minus low by 2. To calculate the mid, this method is recommended instead of high plus low by 2 because high plus low can actually give you overflows. Hence, to avoid overflow, we use this method. Now we will check that if check of mid is true, which means this check function will basically check whether, considering that the number of months are mid, the amount of wood is greater than equal to W or not. So if this is true, then we initialize our current answer to mid and we decrease our high to mid minus 1. Else, we will just increase our low to mid plus 1. Now we can write the check function as it accepts the number of months m, and to calculate whether the total wood is greater than equal to W or not, we first calculate the total wood by iterating over all the trees. And in this we can check, let us say that the height of the current tree is h. This is equal to h of I plus r of I star m. And if this is the tree that we can cut, given by if h is greater than equal to L, then in this case we can add the wood to the height to the total wood. Finally, we will return whether wood is greater than equal to W or not. Now, one of the important thing to notice is that Ri and M can both be 10 to the power 18. Hence, this can give you overflow. To avoid this, what we can do is, instead of checking h greater than equal to L, so in the condition we have hi plus ri star m is greater than equal to L. Instead of checking this, we can check whether m is greater than equal to, we transfer li and ri this side, li minus h of I divided by r of I, and we take the ceil value. So instead of checking this condition, we will check whether m is greater than equal to L minus h of I upon r of I or not. Another thing is that instead of directly adding h to our wood, we can first try to add h of I and then we can try to add r of I star m, so that the variable wood does not overflow. And as soon as the wood is greater than equal to W, we can return this from the if condition directly. Moving on to the complexity, in the above solution we are doing two operations. First, we binary search the answer and then we calculate the number of total amount of wood and check whether it is equal to W or not. So the complexity of binary search is order of log of 10 to the power 18. This is because we first take a range of size 10 to the power 18 and each time we divide the size by 2. Hence the complexity is log of 1e18. Now the check function is order of n because we iterate over the array of trees and check whether the total amount of wood is greater than equal to W or not. Since we are doing this for every search which is equal to mid, the complexity becomes the multiplication, which is n log, and this can be actually written as answer. This is our time complexity. For the space complexity, we just need to store the initial trees, hence the space complexity is order of n, where n represents the number of trees. Now let us move on to the code. In the code, I have used this struct tree to store height and the growth rate. Now we process the input. Now we apply binary search into our answer variable. We have lower bound, upper bound, and we iterate until low is less than equal to height. We calculate the mid value. Possible is the variable that will tell us whether the check function returned true or false. If it is possible, then we initialize our answer to mid and we decrement our upper bound. Else we increment our lower bound. Moving on to the check function. In the check function, we have this variable total wood that will calculate the total amount of wood in this many months. Now we iterate over every tree and we will check whether month is greater than L minus height by growth rate and its seal value or not. If it is, then we know that we can cut this tree. So we add height to the total wood and again check whether it is equal to W or not. If it is not, then we will add month star growth rate, which is the extra height that the current tree has grown, into our total wood, and we will check this again. Finally, we will, for safety, we will check it again and we will return true and false accordingly. Finally, we will print our answer. So guys, this is pretty much the whole code. Try to code it yourself, and if you face any issue, then come back and see it again. So guys, I hope you understood the problem clearly. If you have any questions, drop a comment in the comment section, like the video, and don't forget to subscribe to get our latest updates from CodeChef. Thank you and goodbye.